Hello, in this lecture we're going to talk about relative motions and especially relative velocities. Okay, let's consider this beam which is fixed at point A and the free end which is point B can't move. So if that's the path, this path will be a part of a circle. Let's say this rod, this shaft or whatever it is, can move with the angular velocity of omega AB, and this is the direction of the angular velocity. In this case, I know that the velocity of point B will be the distance between point A and point B, which is AB, times the angular velocity, which is omega AB. This is the same r omega that we learned before. So this is the amount of velocity at this point for point B. Because velocity is a vector, so whenever we want to describe a vector, we need two information. One of them is the magnitude and the other one is the direction. If we are rotating this way, the direction of the velocity will be something like this, and that's parallel or tangential to the path. The important thing here is this velocity is always perpendicular to the rod or to the beam. So I'm going to say this is the magnitude, this one. And the direction of VB is perpendicular to the AB, to the rod. I could say that this is my R direction and this is my theta direction, and it is in theta direction. I could have said that VB is AB times omega AB. That's the magnitude, and the direction is in u theta. But I prefer to say this is perpendicular to the rod because maybe that's easier down the road when you want to use relative motion. Okay, so this is the velocity of point B when point A is fixed. In order to analyze any questions in this chapter, this is the only information that I myself need to know and use. Okay, so if I remove the support here at point A and I let this point move, so if this is my point A and this is my point B and this is my omega AB, again I want to find the velocity for point B. The velocity of point B can be written as velocity of point A plus velocity of point B with respect to A. This is called relative equation for the velocities. So velocity for point B is velocity of point A plus velocity of point B with respect to A. If I fix point A, this means that by fixing point A, the velocity of point A is 0. So what remains is velocity of B with respect to A. And from the left side we have velocity of B. In the previous slide we found that the velocity of B is the length of the rod AB times the angular velocity omega AB, and in theta direction. Okay, so this is from previous slide. If I substitute this guy here, I can find velocity of B with respect to A. So velocity of B with respect to A is AB omega AB, and that's the magnitude, and the direction of velocity of B with respect to A is perpendicular to AB. Okay, so these two are very important they're very important equations that we found at this point. We found the amount of relative velocity, and we found the direction of relative velocity. V B over A, V A over B, C over B, whatever, like when we have a fraction here, this notation means that we are facing a relative velocity in the question. So V B over A means velocity of B when A is fixed. Okay, so V something over another things is velocity of nominator when denominator is fixed. In another word, this is this situation. When A is fixed, we found the velocity of B here. So whatever we found here is the velocity of point B when point A is fixed. Okay, so I'm gonna have some examples here. In this example, point A is fixed, and there is one rod from point A to point B. This angle is beta, this is theta, and point C, there is a box here, and this box is limited, the motion of this box is limited in this way. So it cannot have any arbitrary motion. It just can move through this slider like that. It can have a back and forth motion. So, for example, in this question, AB is given 5 meters, BC is 10 meters, theta is 30 degrees, beta is 120 degrees. Angular velocity of link AB is 30 rpm. So this is the amount of velocity, and the direction is counterclockwise. So this is 30 rpm. And this is omega AB. Maybe I can keep omega AB, and I can't find everything based on omega AB. And we are asked to find the angular velocity of link BC, this link, and the velocity of block C. Okay. The first thing I'm going to do before starting to solve this example is converting this RPM to radian per second. So 30 RPM equals to if I multiply this 30 this RPM, let me tell like this. This RPM is round per minute. It's round per okay, sorry. It's round per minute. I want to have radian per second. So this minute has to be changed to seconds. So I can say 1 minute is 60 seconds. Because these two terms can be cancelled out. So I have round per second. But I want to have radian in the denominator. So and I want to somehow get rid of this round. So I can say 2 pi radian is 1 round. Okay, so this round will be cancelled out, and what remains is radian per second. So the omega AB will be 30 divided by 60 is 2, and this is p, so that will be pi, and which is, for example, 3.14 if we just need 2 digits here, and that's radian per second. So in the first step, I converted the angular velocity from RPM to radian per second, because we are working metric system, and this has to be the unit of angular velocity when we are working metric system. Okay. The second thing I'm gonna do is find velocity of point B. So velocity of point B is like what I said in two slides before. That will be AB times omega AB. And that's the magnitude of the velocity. So velocity of point B, AB is given, and that's 5, times omega AB, which is 3.14. So the answer will be 15.7 meter per second. Okay, so that's the velocity of point B. The direction of velocity is perpendicular to the rod. So if this is the line perpendicular to the rod, we are rotating this way, so this will be, so this is 90. This will be the velocity of point B. Okay, so I'm gonna show that one again here. This will be VB, and we found VB, the magnitude is 15.7 meter per second. Okay, and this is 90, and this is the direction for omega AB. Okay, now I want to find the velocity of point C. Velocity of point C is velocity of point B plus velocity of point C with respect to B. Okay, so here I'm gonna have some assumption. For example, I'm gonna assume when this one is rotating this way, this rod will rotate that way. It's just an assumption. It shouldn't be very accurate. I mean, the direction is arbitrary. It shouldn't be exactly the way that we are rotating. So I'm gonna call this one omega BC. If at the end omega BC is, for example, 2, 4, 6, some positive number, it means that we are rotating this way. If we found something negative like -2, -3, -4, it means that the real direction was that way. But as long as we have our assumption here, we don't need to change our assumption. So this is omega BC, and I'm gonna make an assumption for the direction of motion of block C. I'm gonna assume the block C will move this way, so that will be my VC. Someone could assume that this block can go this way, but anyways, that's an assumption. Based on this assumption here, the velocity of point C is some amount of velocity, and this is in positive I direction. It doesn't have any component in Y direction, so something in I direction. Okay, velocity of point B is this guy. Velocity of point B is 15.7, and this is the direction. this is velocity of point B, and this is, if I draw a horizontal line here, in this question, this is 30 degrees, so this will be 30 degrees, so the whole angle here will be 120 degrees. So that's the velocity of point B, the magnitude and the rotation, and the direction, sorry. Velocity of point C with respect to B. We said that whenever we have something like this, we need to assume that the point B is fixed. So velocity of nominator when denominator is fixed. So we're gonna fix this point. This means that we have a support here, and velocity of point C with respect to B will be, the magnitude will be the length of the bar, which is BC, times omega of the bar, which is omega BC. This is the magnitude, so it's like that R omega that we had. So velocity of point C is R omega. And the direction is always perpendicular to the rod. So this angle is 90. So this angle here, this is the direction. Okay, so if this angle is 30, this is 90, this one is given to us, beta 120, so this angle here will be 30. Okay, 120 minus 90 will be 30 here. And if this is 30, if I continue like in this triangle, like this one, this angle is 30, this is 90, so this one should be 60, so this one is 120, and this one is 30. Okay, so, and this is 60 because the whole angle is 90, so this angle here is 60. Or you can use your own method to find the angle. Okay, once we got these information, we can just substitute these three vectors into our relative motion equation and find our unknowns. I'm gonna delete this one. I'm gonna substitute everything here. Okay, VC is VC times I. So here is VC I equals to VB. This is VB. So if I want to, this is the magnitude. If I want to put that one here, I need to change this one to the vector. So what I need to do, I need to change this one to sine and cosine. This vector here is, so if this is 120, this angle is 60, this is minus cosine 60 in I direction minus sine 60 in J direction. Okay, so I'm gonna say VB, which is 15.7 minus cosine 60 in I direction minus 15.7 sine 60 in J direction. And for this one, it is cosine 60 in I direction minus sine 60 in J direction. So I substitute this one, I substituted this one, and now it's time for VC over B. So the value is BC times omega BC. We don't know about omega BC, but BC is given to us, which is 10. So that will be 10 omega BC cosine 60 I minus sine 60 J. Okay. So let me delete these ones. Okay. So in the left side, the coefficient of I is just VC. Let's see what we have in the right hand side. We have minus 15.7 cosine 60, minus 15.7 cosine 60. This is J, another I here, plus 10 omega BC cosine 60. So this is for I. We don't have any other I in the right hand side. For the J, in the left hand side, there is nothing, so that is 0. In the right hand side, we have minus 15.7 sine 60 and minus 10 omega BC sine 60. Okay, so from the second line, we can find omega BC because that's the only unknown that we have here. So omega BC from this line will be these two signs will be cancelled out from both sides, and it will be minus 157 radian per second. And if I substitute that number here, I can find VC. So VC will be so this is minus 1.7 times 10 will be minus 15.7. We have another one here, so that will be minus 2 times this guy, and cosine of 60 is 1 over 2, so that 2 with the other 2 will be cancelled out. So that will be minus 15.7 meter per second. So what I found here, I found that omega BC is in the other direction, positive 1.75 in the other direction, or minus 1.75 in this direction, and VC is minus, actually it's going this way, but that's minus 15.7 in this direction if this is my coordinate, or positive 15.7 if that's the coordinate. And these two were what we were asked in the question. We were asked to find the angular velocity of rod BC and the velocity of point C. So if I want to summarize what I did for this question, I just wrote the equation for relative motion, and I used the coordinate. I used XY coordinate like this, and then I wrote as much as I could for each term. Then I wrote an equation for I, for the coefficients of I for the left side and right side, and I made them equal, and I did the same thing for the J direction. And from these two lines, I could find the two unknowns. That there are two equations, two unknowns. If I look at this problem is like when we have something like a rotor or engine that's rotating like this, and this block can goes forward and backward in a slide. in a slider. And this is a very, very common question or scenario that we see in almost all machines. Let's go to example number 2. In this example, we have two slider and two blocks. The motions of these two blocks are limited by the slider. So block number A can go up and down, and block number B can go right and left. So in the question, the amount of AB is given to us. The amount of the rod is 20 centimeter. The velocity of block A is 10 meters per second upwards. So it has a velocity like this, which is 10 meters per second, and this is 20 centimeters. And we are asked to find the velocity of block B. Okay, so again, for finding this question, I'm gonna make an assumption. So my assumption is this is the omega AB. The direction of omega AB is my assumption, and based on that, I'm gonna make this assumption. So that's the velocity of B. You could do any arbitrary assumption that you wanted. It doesn't make any differences at the end of the day. So I'm looking for the velocity of point B. So velocity of point B is velocity of point A plus velocity of point B with respect to A. Okay, so let's see what we know about velocity of point B. Velocity of point B, based on my assumption, if this is my coordinate x and y, is VB, and that's in I direction, so that's I. Velocity of point A, this is 10, and that's upwards, 10j. That's vector. Velocity of point B when point A is fixed, so that is velocity of point B with respect to A. So it means that we fix this point and we're going to find this velocity. So we said that the magnitude of this velocity is length times omega. So length here is 0.2 omega AB, and we said that the direction is perpendicular to the rod. So this will be velocity of B with respect to A, and this is perpendicular to the rod. So this is the direction of the velocity of B with respect to A. So in this question, theta is not given to us, but the examiner said this is theta and this is theta. So because the summation of angles in a triangle should be 180. So if this is 90, 2 theta should be 90. So theta will be 45 degrees. Or the examiner could give us the amount of theta, but we could find it from the dynamic of the system. Okay, so if this is 45, this is 45, so this is 45, so this angle is 45. So I'm gonna and where did it go? Okay, sorry. So I'm gonna substitute these three terms in this equation. Okay, velocity of point B, this is VBI, equals to velocity of point A, this is 10j, plus velocity of point B with respect to A, this is 0.2 omega AB, and the direction, this one is cosine 45 I minus sine 45 j. So that is cosine 45i minus sine 45j. All I need to do at this point is to find the coefficient for I and j at each side and make them equal. In the left side, coefficient of I is VB. Here, the coefficient of I is 0.2 omega AB cosine 45. We don't have any other things here. The coefficient of j here is 0, and the coefficient of j in the right hand side is minus 0.2 omega AB sine of 45. And we have one j here, plus 10. Okay. So from the second equation, we can find omega AB, which is minus 70.71 radian per second. And if I substitute that number here, I can find VB this is positive here, because when it goes to the other side, that changes to positive. So I can find VB, and VB will be 10 meter per second. So you see that with just one simple equation, I could find the two unknowns that I had in this equation, and I just asked to find the velocity of B. But I also found the angular velocity of this rod. Okay, let's look at this example. This is exactly the same example, but this rod is longer, and we are asked to find the velocity of point C at this time. And in this question, theta is given to us, is 45 degrees. So it could show this angle to us and say this is theta, but here it just says that this is 45 degrees. So we know that this is 45, and the velocity of point A is the same as the previous question. This is 10 meters per second, and this is 2 meters and 20 centimeters, and this is 1 centimeter, 10 centimeters. Okay, can remove these numbers here. So this is omega AB. From the previous question, we found that omega AB is 70.71 radian per second. And we found that the velocity of point B is 10 meter per second. Okay. And this is in this direction. Here we are asked to find the velocity of point C. So I can say velocity of point C equals to velocity of point B plus velocity of point C with respect to B. Velocity of point C, here I'm gonna make I'm gonna say I don't know anything about the velocity of point C, so I'm just writing velocity of point C. And for velocity of point B, I found that from the previous step that is 10 meters per second, and that's in I direction. Okay, that was this way. Velocity of C with respect to B. It means that when point B is fixed, we want to find the velocity of point C. So if this is our omega BC, this will be velocity of c with respect to b. That's velocity at c with respect to b, perpendicular to the rod here. So sorry, my computer got crashed, so I had to pause the video. So for the velocity of point C, we said that is velocity of point B plus velocity of point C with respect to B. And we said that this is velocity of point B, which is 10, and this is omega AB, and this is omega BC, and that one was velocity of point C with respect to B. Okay, so for velocity of point C, we don't have any information, so I just leave it like that. Equals to velocity of point B is 10, and the direction is I, plus velocity of point C with respect to B is BC, which is 10 centimeters, times omega BC. That's the magnitude, and the direction, this angle is 45, is cosine 45 I minus sine 45 J. Okay, so I can say the velocity of point C is equals to 10 plus 1 point omega BC cosine 45 in I direction minus 0.1 omega BC sine 45, and this is the component in J direction. So in this question we are asked to find the velocity of point C, and we found that this is the velocity of point C in this is the component in I direction, and that's a component in J direction. There is one thing here, because this rod is just one rod and it doesn't have any, it's not a combination of two rods pinned together, so angular velocity of the rod should be the same. So if I just look at this part, if it's omega AB, that has to be the same as omega BC, because it is rotating with the same angular speed. Okay, so omega AB is equals to omega BC, even equals to omega AC. Maybe someone wants to find the velocity of point C with respect to A. So he or she should write VC equals to VA plus VC with respect to A. So angular velocity is the same for the whole beam. So here we have omega BC. We found omega AC in the previous step. So we can just substitute that value here, which was 70.71. So we're gonna have 10 plus 5 I minus 5 J, so that will be 15 I minus 5 J. So that's the velocity of point C, which we are asked. And if someone wants to find the magnitude of the velocity, that's so easy. So we just need to find the square root of 15 squared plus 5 squared, which will be 5 square root of 10, and 1581 meter per second. So that's the magnitude of the velocity, and the velocity is 15 in I direction and minus 5 in J direction. Okay. Now I'm going to give you an example, and I'm going to ask you to find the velocity of point C, the same point, but in this question, this slider makes an angle with the horizontal axis, which is beta. And I'm going to ask you to find the velocity of point C when beta is 30 degrees. If you have any questions, or if you think that you may need the notes, feel free to send me an email at engineeringfun2016@gmail.com. Thank you for your patience.